begin our coaster maze, we'll navigate to the open source maze generator website, mazegenerator.net. And here we just have a few tabs to fill out. We're going to be doing a circular maze. And I found that a maze with a cell diameter of around 10 to 15 works best. So I'm going to choose 12, a little in between, and select generate. It generates a random maze profile. And we're going to download this as an SVG file. So I'll select SVG and download. Now we'll open up Fusion 360. So now that Fusion is open, I'll come over to the data panel. I want to navigate to the home folder, and I want to ensure that I'm on the CSI Makerspace team, and then the folder that I'm going to be using, project folder, is this collaborative making project, and I will select my folder. If I can give it back. If you haven't yet created a folder, you can create a folder with this new folder tab. And I'll go back into my folder. I'm going to save this. Coaster maze. Save, and I'll minimize the data panel by selecting the X or the series of squares there. So to get started, we will initiate a sketch by selecting the sketch icon and choosing the top plane. We'll come over to Insert. We're going to insert an SVG and select the folder icon and our 12 cell diameter theta maze. Do OK. Zoom in here. Now the SVG comes in as a green colored line segment, and that means that all these elements are fixed. So we're going to unfix them by selecting the lock icon, and we'll drag a window around everything, and then escape to get out of the lock tool. Now I want to have a little cubby here for the ball bearing to start from. So I'll go over to Create, select the arc tool and a 3-point arc. And I'm just going to snap to the 2 endpoints. And I'm going to zoom in here and just drop it in place. Now our coaster maze will need to be approximately 4 inches overall for the ball bearing to have enough room to move. So I'm going to D on the keyboard for dimension. I'm going to place a dimension. So currently our maze is 2 inches in diameter. So we want to expand this out by using the scale tool. I'm going to come up to modify, and we are going to use this sketch scale. We'll drag a selection box around the entire sketch. We're going to select the origin point. And the scale, this interior portion of the maze, I'm going to shoot for 3.5 inches. So we can select 3.5 divided by 2 would be the scale factor. And to double check, we can do D on the keyboard for dimension. And we can see that 1.75 times 2 would be 3.5 inch diameter. So we're done with that portion of the sketch. We're going to finish sketch. And then we will develop another sketch on the same plane that will be the outside profile of the maze. So we can select C on the keyboard or come over to create and select circle with a center point. And we'll select near the center of our current maze and drag a circle out. D on the keyboard for dimension. And we want this to be 4 inches. And looking at it, I'm going to go ahead and make this a little bit bigger. I'm going to make this 4 1/4. So we have a little more room to fasten a top onto our maze. So currently I haven't constrained where the circle goes, so I need to do that. And to do that, we are going to use P on the keyboard for project. And we're going to select our original maze profile along with the little pocket we created. OK. And we're going to select a concentric constraint. And that will place the outside circle concentric to the inside maze circle. Say OK. So now that we have our kind of 2D sketches created, we're going to need to translate these into 3D shapes. So we'll navigate up here to the toolbar, select the surface tools, create, extrude. I just want to extrude the interior maze components. So I'm going to hide the outside profile sketch, drag a window around our maze sketch, and we're going to extrude this up 1/8 of an inch, so 0.125. Select OK. Now this generates a bunch of surface bodies. So we have, looks like 21 surface bodies. Now surface bodies we can't machine to, so we're going to convert these into a solid body. And to do that, we'll use the thicken tool. So before I go to the thicken tool, I'm going to select body 1 and shift select body 21. Come up to create, and at the bottom, thicken. We're going to do a symmetric thicken, and we'll give it a value of, try 0.06. Select OK. And it created, if you notice, it created a new body 22. These original bodies are not necessary anymore, so we can go ahead and move them out of the way by selecting body 1, shift selecting 21, right click, and remove. That just cleans up our tree over here a little bit. This is a good point to save. I'm going to save. So now we'll continue extruding to fill out the rest of our maze shape. We'll navigate in the toolbar up here to the solid workspace. We'll show sketch 2, and we'll use the extrude tab to extrude all of the sketch 2 maze. And we're going to extrude it down. It's going to be the thickness of our material, which is 0.47. I measured it earlier. And we'll offset it by adding the thickness of our first extrude, which was 0.125. And we want to make sure join is selected, so it's all one element. Say OK. The next thing we'll do is extrude this portion up to this surface here. So again, we'll show sketch 2, and E on the keyboard will also let you extrude, and we'll select this outside profile. And the extent here, the distance, we'll select to object and select the top face. Now by default, it wants to cut this face. So the operation We'll change this to join, say OK. So at this point, we have the base portion of our coaster maze. Now we want to extrude the lid or cap that'll go on here. It'll be a transparent Lexan cap. So I can hide this body for a second, body 22, our main coaster body, and E on the keyboard for extrude, and we'll select all of the profile. I'm going to show the body again. And our extrude start point, we'll come over here and select from object, and we'll start our extrude from the top of the maze, and it will be a distance of 1/8 of an inch, 0.125. That's the thickness of our Lexan. And the operation, we want to make sure we select new body. It's going to be a separate body. Say OK. And we'll hide these sketches so we can see our two bodies. Now body 2 in reality is transparent, so we'll come down to the opacity control, right click on the body, opacity control, and 50% opacity so we can see more or less what it's going to look like. This is another good point to save. I'll select the save icon. So now that our model is mostly complete, we'll navigate to the manufacturing space. Select design, manufacture, and this is where we'll set up our CNC toolpaths. So the first thing in the setups is to initiate a new setup. Within the setup, we'll be defining what the stock size is and the orientation of the machine relative to the part. So the first thing we'll do is orient our work coordinate system. So the Z-axis is always perpendicular to the face that we'll be cutting. And to modify this, we'll come over here to the WCS work coordinate system and select model orientation, the Z-axis, and we'll convert our current Z-axis to be the Y-axis. And the other thing I like to change here is the origin point, our center point. I like it to be in the lower left-hand corner when I'm machining on the ShopBot or Xcarve. So I'm going to select this box point tab and move that over. Now, the next thing I like to do is define what's going to be machined. So this first operation, we're going to be cutting the bottom portion of the maze. So we want to select this model tab, drop down our model tree over here, open up the bodies, and we're going to be working on body 2. I'll go ahead and hide the upper Lexan piece while I'm in there. Now we need to define what the stock is. So we'll come over to the stock icon. And the default for Fusion is this relative size box. We're going to go ahead and use that for now. And the only change we'll make is to remove the offset of the material, so it'll be a 0 offset. And now you'll notice that our Z height is the same as our true material height. And our X and Y dimensions are slightly bigger than our final part size. Select OK. Next thing I want to do is check to make sure that cloud tools are enabled. So if you come up to your user preferences and navigate to the manufacturing tab, I want to ensure that this enable cloud libraries is selected. Say OK. So now we'll start to set up our toolpaths. So I'll come up to this 2D toolpath dropdown, and we're going to do a pocket path. We're going to pocket out this maze, select this maze area. So within the toolpath work window, I usually move from left to right to check these tabs. We won't be checking all the tabs, but as you get to know the machining better, you'll want to get familiar with what they all do. But for now, we're going to select a tool. So we'll go to the Tool Select tab. And on the left-hand side, it shows us our current document, which is the coaster maze. We have some Fusion library information here. And then we have our cloud libraries. If you don't have this Xcarve tool package, we can provide that for the course, and we'll show you how to download that. But if you've already done that, you should have access to these tools, and we'll be selecting the flat end mill, the 1/8 inch flat end mill. So double click on it. And then the next thing we need to do is select the geometry that we want to cut. It's going to be this lower face of the maze. And the only other change we're going to do is this this compensation type. We're going to change it to conventional. And we're going to use multiple depth cuts because we're using a very small bit. If we try and remove it all at one time, it's going to break the bit. Select OK. And we can see our tool paths going in there. The next tool path we want to set up is this outside perimeter cut. So we'll come up to 2D, and we're going to use a contour toolpath. And by default, the 1/8 inch bit is already pre-selected, and we're going to continue to use that. Select geometry. And the profile will be this lower profile. And we'll make the same changes on this toolpath. So it will be the right-hand compensation. And we'll scroll down to do multiple depths. And we'll use that default of 0.04. Say OK. So now we have an outside cut and an interior cut. We'll go ahead and control select the two of them, and we'll do a simulation to see how our part is going to look. So we'll come up to simulate. And within the simulation, the default actually is generally the tools are shown but not the stock. And I prefer the opposite. So I'm not going to show the tool and the tool path. I'm just going to show the stock. And I'm going to hide the model and press play. We can speed this up a bit, and we'll get a very accurate representation of what our maze is going to look like. And that looks good. At this point, if you have any issues, if it doesn't match up to your model, the most likely scenario is that the maze is too small. There's not enough room for the bit to get into all these places. So we have to go back in and adjust the model. But this one looks okay, so close. Go ahead and show the model again. And to keep everything organized, you may want to rename this setup as the maze bottom setup. So we're going to minimize that. And we're going to do a new setup to do the top Lexan cover plate. So we'll come up to setup, new setup. And this time we'll hide the bottom and we'll show the top portion. We will select the body as this bottom, deselect that. We'll come to the work coordinate system and select our axis there. We'll move this to the corner. And we will look at, so Fusion, as we do new setups, after the first setup, it uses the old setup as its default. So we want to come back, do this drop down and select the relative size box again. We'll do a 0 Z offset. So we double check that our Z is the same as our material thickness. Say OK. And we're going to do a 2D contour. The tool is already pre-selected. So we'll select geometry, which will be the lower portion of the circle. And again, we'll change this to the right-hand compensation. Go ahead and do multiple depths on this as well. And say OK. Now we can select it again and simulate. There we go. So this is a good point to save. So the next thing we need to do is export this to the machine. So we need to select, we will export first this setup to, and I renamed the maze bottom, so I'll go ahead and rename this one by slow clicking on it, maze top. I'm going to select the contour, and this G1, G2 tab is the post-process tab. So what this will do is convert the Fusion code into G code that our CNC machine can operate with. So in here, I usually make sure my output folder is where I want it to be. I've been putting it on the desktop. I have a CNC post folder. I'll select that folder. And the next thing we want to do is select the correct post. If you're working on your own computer, you probably won't have any posts. So we'll provide instructions on how to acquire posts. If you're working on a computer in the makerspace, we have all of these posts on the machines. The post is specific for each machine, so you have to select the machine you're going to be using. So in this case, I'll be using this easel by Inventables, and select post, and we'll give it a name. Maze top. So the last thing we need to do is send out these programs to the machine. And to do that, we'll select the toolpath that we want to run. We'll come up to this G1, G2 tab, select that, and this brings us to the post processor. It converts the Fusion modeling information into G code, which is what the CNC machines use to operate. So I come down to the output folder and make sure that it's going where I want it to go. I've been putting mine on a desktop folder. And then we need to ensure that we're using the correct post. So we have, on this machine, I have the easel Inventables is the X-carve post. We have a Haas post, Mach 3 for the plasma cutter, and Shotbot post. So I'm going to select the easel Inventables post. We will provide instructions on how to download these posts if you're using your own computer, but if you're using the computers in the shop space, you should have, each one has access to all of these posts. We can name our program here, or we can post it and name it at posting. I like to name it at posting, so this will be maze top profile cut. And then we'll do the same for the maze bottom. So we'll select, Control Select. If we, for the X-carve, if we had two different tools, we would want to export these out as two separate files. But we're using the same tool, so we can export them out together. And the Inventables is already selected, and our folder is already selected, so we don't need to manipulate those, so we'll just post. And this will be maze bottom, profile, and pocket. One more quick note. The order is fairly important. So, and we can change the order of these by dragging and dropping. But as I select them, it's going to run in the order that they show up here on the screen. So this configuration would have the contour run first, followed by the pocket. And that's probably not very ideal because we lose the ability to hold the part if we do the contour first. We might lose the part on the CNC as it's running if we're running this pocket secondary. So if you had created the paths out of order, you can rearrange them by just dragging and dropping. So now we will go to the machine and cut the part. And this is a good point to save.